Here's another 3-loop mesh analysis example. And in this example, they're asking us to find the current through the 5 ohm resistor. So that would be the current through this guy right here. And just need to find some mesh currents and get to work on this. So if we do that, we're going to define some mesh currents, and we'll call this one I1. We will call this one I2, and then we'll call this one I3. And so we should see what we're really solving for then is I2, because I2 goes through the 5 ohm resistor and it's not shared, so it should just be that value. So let's go ahead and see if we can set up the mesh equations here. So for the equation associated with the loop for I1, we should see that this current goes through the 8 ohm, the 2 ohm, and the 7 ohm resistors. So that's 17 ohms. So we should be able to write that then as 17 I1. But then we also note that I2 goes through the 8 ohm resistor, and it goes in the opposite direction, so it's be minus, so that'll be minus 8 I2. And similarly, with the 2 ohm resistor here, we see I3 goes through that, and it's going in the direction against our I1, so that's going to be minus 2 I3. And we also see we have this voltage source here. So as we are traveling around the loop, we see that we encounter the negative sign first, so that's minus 5. And then finally, we should notice we have this voltage source here as well. And this one, when we come in the direction of the current, we hit the positive signs first, so that's going to be plus 7. So that's everything in loop 1, or the loop associated with I1. And so if we add those together, we should get 0. So now we want to go to the loop associated with I2. And so in this case, we see we've got the 8 ohm. We already have it highlighted, but we also have a 6 and a 1. So that should give us 15. So if we write that out, that's going to be 15 I1. But we already know the 8 ohm is affiliated with I1. It's going to be in the wrong direction or against our flow. So it's going to be minus 8 I1. And then likewise, we see in the 6 ohm that it's got I3 going through it in the wrong direction, or the opposite direction, I should say. So that's going to be minus 6 I3. And also left off this 5 ohm, this 5 ohm resistor. So that adds another 5 ohms. So I need to correct that. So this is not 15. That's going to be 20. So let's correct that. So that'll be 20. All right, so that's everything affiliated with that. So we can set that equal to 0. And then finally, with the third and final mesh, the one affiliated with I3, we already have the 2 resistors in that. They're highlighted green. It's a 6 and a 2. So then that's going to be 8 times I1. But we know that the 2 is affiliated with I1 in the opposite direction. And then we know that the 6 is affiliated with I2 in the opposite direction. And we know that we have 2 voltage sources in and this loop as well. Sorry, let me get my colors right. And so as we come around on those, the first one we see we hit the negative first, that'd be -7. And as we come around this way, we hit the minus side again, so that'd be another -7. And so we can set then that equal to 0 because that's everything involved with that loop. So now we should be able to gather like terms and rearrange things a little bit. When we do, we should have 17I1 minus 8I2 minus 2I3, and then that's going to be equal to -2 for that one. For this guy, we're going to have -8I1 plus 20I2. Oh, that should be a 2 right there. And then -6I3. And then that's all going to be equal to 0. And then finally on the last equation, we'll have -2I1, should be one there, and then -6I2, and then plus 8I3, should be a 3, and that's all going to equal to 14. So now we've got our 3 equations, 3 unknowns. Again, you can use any method available to you in linear algebra or algebraic manipulation. But when you do that, the one we're interested in is I2, because that's also equal to I 5 ohms, which is this current flowing right here. And when you plug all this in and calculate it out, that should give you your answer.